from the Department of Financial Studies and Business Economics. Professor C.P. Gupta really needs no introduction, because I think he's well known in the area of not just research, but also in imparting learning and knowledge to students, even someone technologically challenged like me. I remember listening to his lecture once, could pick up quite a lot of new aspects in terms of my research. And I think I'll never forget when one of the resource persons we had called last semester, Dr. Neeraj Kaushik, at the behest of Professor C.P. Gupta, he touched his feet and said, "Sir, you are my mentor and guide, because it is your workshops that I had attended before I began starting my own." So I think, friends, we have someone as accomplished, as astute a scholar as Professor C.P. Gupta. And I think for you, it's not only a privilege, but for all of us, it's an honor to have him with us. Thank you so much, sir, for accepting to
Thank you for
be
the
our
nice
resource
words, and
person.
thank you for the
Thank you so much,
appreciation.
sir.
Okay, thank you, thank you. Should we start?
Yes,
Ji, sir.
sir. Please, sir.
Okay, good. अंजलि सब ठीक से काम कर रहे हैं ना, ऑडियो वीडियो एवरीथिंग?
Yes, yes, sir.
We
Everything is fine, sir.
okay.
Start,
Yes,
sir.
sir.
Sorry for
Yes.
a little delay, but hopefully we will pick it up.
Ji, sir.
Okay, good.
Ji, sir.
So friends, good morning to all of you, and again welcome to the session on your time series and panel data. So okay, so let's start. Today I welcome you to the session on panel data analysis. And friends, today is your day. Start fresh with a lot of energy. Train hard during the sessions, and finally feel proud as a person who has really learned good things in today's session. Okay, so start fresh, train hard, and finally be proud. And to begin with, never forget these words of Steve Jobs, who said that the only way to do great work is to love what you do. And the fact that you have joined this FDP, that shows your love for learning the things, and please keep that love with you and keep it up. Okay, thank you for joining the session on panel data. So today will be the day when you people will be charged with a lot of energy, a lot of concentration, and your cooperation will be highly appreciated throughout the session. Okay. Right, so suddenly, you know, it's time to start something new and trust the magic of beginning. And I hope all of you are ready for it. Okay. Right. So welcome again to the session on panel data. And let's proceed with the thought. It says, let everything you do be done as if it makes a difference. And that's very important. Whatever you are doing, please ensure that you are making a difference. And as a researcher, we expect all of you that whatever you contribute, it must make a difference in the academic world. And I wish you all the best in your research endeavor. Do well, do good, and hopefully at the end, God will bless you and you will do wonderful research. Okay. So now let's take certain things which we have to learn as a teacher. I just, I think if you want to see that video, I can share with this video with you. Sorry. There are certain things which as a teacher we have to learn. I'm taking 1 or 2 minutes of you. Okay, so please appreciate difference between why and why not. And as a researcher, you should always ask this question, why? Why not this? Have a different way of thinking. Okay, that's what we have to appreciate. So trust that this workshop will prove to be a milestone in your learning experience. So let's dare to enter the world of panel data, and the software which we'll be using for panel data analysis will be Stata. And to begin with, we will have some familiarity with this data and do some basic regression. But nevertheless, the exercises which we are going to do will give a lot of lessons that we are going to use for panel data. So get ready for it. But first a quote. It says, friends show me what I can do. Foes teach me what I should do. And both are important. Friends are important. Foes are also important because we learn something from both of them. Okay. So friends show me what I can do. Foes teach me what I should do. Okay. Let's take this philosophy in econometrics. What do you think? What is the best friend in econometrics? Any one of you guess? Anyone who can guess what is the best friend when you do econometric exercise? Mathematics, data, variables, random variables, software, regression, all those things you are saying. But I'm talking in a very specific context, and that is in the context of econometrics. Okay, so the best friend in econometric is OLS. Simple, intuitive, easy to use. And the best thing about OLS is it gives you blue estimates. Best linear unbiased estimators. And that's the best thing about OLS. And as a friend, we always prefer to use it as far as possible. And once we find that it is not possible to make use of OLS, then we start getting challenges, and we are in trouble in that case. So friends, the best friend in our econometric modeling is OLS. Help us in getting the best estimates which are available to us. Please remember, friends show me what I can do. Foes teach me what I should do. OLS show me what I can do in econometrics. OLS says that you can get the best estimates by making use of this estimator. Okay. Now, who is the greatest foe in our econometric exercise or in econometric modeling? Bhuvnesh Kumar said error. You're absolutely right. The foe is error term which we have in our model. Sorry. It is the error term which is an enemy for us that creates a lot of problem. And you might be wondering why error term is our foe and enemy. Okay, for understanding it, let's look at the assumptions which we make for getting the blue estimates by making use of OLS. Error term mean is 0. Variance of the error term is constant. No autocorrelation in the error term. X and the error term, they are not correlated. Error term is normally distributed, and we assume that x's are given to us. They are known non-stochastic in nature, and all x's are independent of each other. If you observe these assumptions carefully and give a thought to it, you will find most of the assumptions are for errors. And we have assumptions because we have to discipline error. If we are not able to discipline errors, then your estimates will not be blue estimates. And that's what people do, impose restrictions on errors so that it start behaving, in a disciplined manner. But error is a foe. It goes in its own way. We may not be able to control it. And when it started violating the assumptions, then we get a lot of problems and you may not get the blue estimates. Okay, so please understand it. If your error start behaving not as per our assumptions, you are in trouble. And when I say you are in trouble, that means your estimates will not be the best, unbiased, consistent estimates. Okay. Uh, One is asking me, are these assumptions also for the panel data? Uh, some of them are not. And that's why we need different methods for handling panel data. Dhruv Singhal is asking, normality check is for error only? Yes. X, we are assuming non-stochastic. So no question of testing assumption about independent variables regarding normality. Okay, y depends upon error term, and if error term is normally distributed, y will also be automatically normally distributed. So friends, when you do regression analysis, it is the error term normality that has to be ensured. And if that is ensured, y will be automatically normal, and for x, we don't care. Is that clear, Dhruv? Okay. So please remember, foes teach me what I should do. The behavior of the error term teaches me what I should do in econometrics. And that's the whole challenge, and that's the whole, the fight in the econometric modeling. So the lesson is always try to use OLS unless the error term becomes a culprit and spoil the things. So the whole fight is in panel data is how to take care of the error term, because the error term spoil the quality of estimates. And that's what we have to confront with, that's what we have to fight with, and that's what we have to take care of. And that's one of the biggest challenge. Okay, so please understand why error term focus is important for us. So let's take the first step, but the toughest step to begin with. And a simple regression equation. Do you see any relation between blood pressure and age of a person? Normally, with age, blood pressure of a person increases, and we have the data with us that shows age and blood pressure. Okay. For us as a researcher, we have to disprove only with the data. And please understand, in God we trust, all others bring data. That means you have to prove it. And for us as a researcher, we have to prove or disprove only with the data. So do you think age is having an impact on the blood pressure? Milind Patil is asking me a question. What is the difference between error term and residual? Error term, normally we talk in the context of population regression function, and residual we talk in the case of sample regression. And majority of the case we work with the sample data, and so the estimates which we get, they are the estimates of the residual. But in a loose sense, you'll find we are using error term and residual in a very in a interchangeable manner. But technically, we do make a difference between error term and residual. Error is for population, residuals for the sample. Okay. Right. So what will be the model? That blood pressure is equal to alpha plus beta age plus error term. And what is the model which is of interest to a researcher? That what we are looking at here. Okay. And if we run regression, what we get that age is having a positive impact on blood pressure. And that says if age increases by 1 year, your BP will increase by 2.86. Okay, right? Now, do you think this is a right model, or we have to do something else in this model? Any guess about the modeling? Anyone? R square is 61%. Yes, Palak, you are right. That means variation in blood pressure can be explained to the extent of 61% by age. RMSE is high. I do not know why you say RMSE is high, because I don't have a benchmark to compare with it. Okay. Vanita Chadda. Vanita, are you here? I'm happy to see you here. Vanita, you're right. And it may be possible that there are certain other variables that also influences blood pressure. And I have not considered those variables. Let's go further and see what is that. Assume that somebody has suggested that weight also have an impact on the blood pressure along with the age. Now, in that case, your model will be your BP is equal to alpha plus beta 1 age plus beta 2 weight plus error term. And that's our second model. And the first model is BP is equal to alpha plus beta 1 H plus error term. Okay. R square high, low, I'm not concerned for the time being. What we are concerned with here is it might be possible that you have missed some important variable into your model. Now, friends, I have a challenge. Should I use this model, or should I use this model? Obviously, you will say that you should go for the second model. Suppose hypothetically assume that I don't use 2, I go for 1. Then what will be happening to my quality of the estimates? Will they still be blue or not? Please understand that. If you omit an important variable from your model, will you still get blue estimates, unbiased estimates, consistent estimates, efficient estimates? Will you get that? Think over it and come out with some answer for that. People are saying no. So if you say no, then why it is not giving you the better results? Where is the problem in it? Okay, but before that, let's understand it. So if I run with weights, my estimate is coming to be 2.16. Earlier it was 2.86. Now the coefficient is 2.16. Now as a researcher, you have to take a call which one is the right one. Kanika Verma is asking, how can we compare unless and until we know that we have omitted some variable? And Kanika, that's the challenge which I want to push through in you. I want to make it clear in you that what will happen, imagine what will happen if you omit a variable which is an important variable. And that's the lesson which I'm trying to infer from this example. Which one is having more influence or less influence? That's not the question I'm going to talk about. Till now, we are just looking at whether we are getting a right model or not a right model. Okay. So without understanding the process of the self, there is no basis for thought. There is no basis for right thinking. And understanding is important. Please don't give it up. Okay. Let's understand what we say. BP is equal to alpha plus beta H plus error term. Okay. And I know that we have a omitted variable weight. Let's assume that I know it, that we have a weighted weight as an omitted variable. Okay. Now the question is, when you run this regression, do you think weight is having any impact on this equation? Srishti, please forget about R square, adjusted R square, because that's not what we are trying to appreciate. Palak Jain is saying indirectly, I don't know. Most of you are saying yes. If you say yes, now think further where that impact is residing. Where that impact is residing, you will find the impact of the weight is hidden in my error term. So omitted variable which you have, their impact will go into the error term. And that's why I always say that error term is my foe. And we do not know what is there inside an error term. Okay, but one thing is very clear. The impact of the variables which are not there in the module will finally find a place in a very hidden manner in the error term. And that's what creates a problem. Okay, if there is a correlation between the age and weight, then you will find that beta estimate which we get, that will be a biased estimate. And if you realize that your estimate is a biased one, nobody is going to accept your results. Okay, so I repeat again, if there is an omitted variable that will enter into your error term, and that will create a problem. So you have to be careful about it. Okay. Right. So many of you are able to appreciate this. So if we omit a variable from our model which is of significance, then we have what is called a omitted variable bias. Sorry. And let's devote some time, because for appreciating the panel data analysis, you must be clear in your mind the omitted variable impact. So assume that we have a model here. That's the correct model. Okay. And we estimate this model, which is a underfitted model. Then the coefficient which we get beta 1 will have a biased estimate. And such a bias you can find out from here. And that's what is called a omitted variable bias. Okay. What is this term? Any one of you can give me an idea? What is it? What it talks about? What it indicates? Sunil is saying covariance, absolutely right. And now imagine if covariance is 0, then your bias will be 0, and you need not to worry about it. So the problem is you have omitted variables, and those omitted variables are having correlation with the variables you have taken in your model. If it is so, then your estimates will be biased estimates. Please keep this lesson in your mind. If omitted variables are correlated with your independent variables and you have omitted them, your estimates will be biased estimates. Okay. Omitted variable bias is bias that appears in the estimates of the parameters in a regression analysis when the assumed specification omits an independent variable that is correlated with the dependent and independent variable. And that's what we say, and that's what we understand. That's beta head. And now you can say that you can see there is a bias. Okay, friends, if your estimates are not blue, doesn't matter. Sorry, I'm sorry. Please listen my words carefully. If your estimates are not blue, then higher R square, adjusted R square, other things will have no meaning. R square, etc. has have a meaning only when your estimates are blue estimates. Okay, right? Dhruv is asking me that if you include a variable, R square increases. That's not correct. The moment you add a new variable, R square will always increase. Whatever amount, I do not know. But adjusted R square may come down. That's possible. Uh, Mr. Dash is asking me, Shakti Ranjan Das is asking me, how do we know that omitted whether our estimates are blue or not? For that, you have to check the assumptions of your blue estimates. Dr. Manoj Dash is saying that knowingly and unknowingly, uh, there will always be some omitted variable bias, omitted variables. I agree with you, and therefore you have to ensure that variables which are omitted, they are not significance, they are having practically no impact on your dependent variable. So variables which are having impact on your dependent variable and they are correlated with the independent variable, try to make sure that they are into your model. And I agree with you, some variable will always be omitted. And as a researcher, you have to take a challenge how to decide whatever is left over is not important for you. Which is asking me error term should be significant or not. No, we don't have any hypothesis testing about error term is significant or not. No, we don't do that. So revisiting our results of the blood pressure, you will find age is having this and age is having now 1.2. And it is because of the fact that there is a relationship between weight and age. So if you see, the right model will be something like this. Age has an impact on BP. Age has an impact on the weight. Weight has an impact on the BP. And that's the model which you have to appreciate and you have to work out. Okay. So note this, this is the expected value of the beta hit. And calculate the covariance between age and weight, correlate this, and you can do it by making use of Stata. I think okay. I do not know how many of you are familiar with Stata, but nevertheless, Stata is very friendly and you can learn it quickly. So friends, let's do that BP exercise with uh, Stata, okay? So please open up Stata. Sorry, I'm not able to see it. Give me a minute. I'm going to open Stata. Friends, we can do this exercise in eViews, but since panel is going to be done through Stata, so I'm doing this exercise through this eViews. But if you don't have Stata, doesn't matter. You can do the same exercise with eViews as well. Okay, so let's first open up a file. So go to File, import Excel spreadsheet, browse the file, send to you, and we have I think your age and BP file is a Stata file. Friend, this is the Stata file, and sorry, you cannot use this file in eViews. So please open up it. It's a .dta file. Yes, Prevrata. Okay, let's learn some quick commands. You can use a summary, SUMM, or you can write the full phrase for summarize. If you use the first 4 letters of a particular command in Stata, it works. Like sum, for example, and you will get a summary of the variables, right? 30 people, 30 blood pressure observation, 30 age, and you have the mean, you have the standard deviation, you have the minimum value, you have the maximum value. Okay, right? If you want to make a histogram, you can make a histogram. Just write hist and type age. And please understand, Stata is case sensitive. So be careful about writing the variable. Just wait, we will get the graph. That the graph we get. Okay, if you want to have a normal curve into it, then you can just type, and to bring back the earlier command, you use page up and page down. Okay, and whatever options you have to write in Stata, those options have to be separated by comma. So comma, normal, and now you get a histogram with the normal curve. Okay, right. Regression. So to use regression, you have to simply type regress. Or you can just write first 4 letters REGR. Pulvinder Kaur is saying it's like walking in R. One similarity is that both are both can be command driven, but Stata is also menu driven, and in R you have to go deeper into the programming, but this Stata doesn't require any programming. Okay, so regress. Another thing which you will find that when you write any command, variables will be separated by space. You can leave one space, 2, 3, 4, doesn't matter. But variables name should be separated by spaces and not by commas. Commas is only for options. So you have the variable names here. If you see, you have the variable names here, and you can take the variables name from here by just clicking them. Just click here, you get the name of the variable. And that's very convenient and comfortable because you may not commit a mistake while typing it. Then age, I run the regression, I get the result, 2.86. Okay, right? If I run the same regression, sorry, with the weight, I get this equation. Okay, if you want to find out what is the correlation between weight and age, you just type correlate age and age and weight. That's the correlation, 0.5631. And this correlation is creating a omitted variable bias. Okay, and another thing which you can see here is, I do not know whether you have observed here or not. Compare the MSC here and MSC here, it's lower. And you can see here the residuals here and the residuals here. Residuals have come down. Why they have come down? Because in the first module, the impact of weight was residing, and that was creating a problem for us. Palak, .dta will be directly opening in Stata. You have to work with it. Okay, any question about it? Any doubt? Okay, let's go back to our discussion. What next is very is important quote. If I were rich, I would buy all your paintings. He said, thank you, my friend, because appreciation is more important, and you should appreciate the creativity in you. Okay, let's take a simple challenge, how to know what relationship exists between price of tea and quantity demanded. And you might be wondering why I'm taking this example, because this is going to give us very important conclusions about what we have learned about omitted variable. Are you happy with these results? T is having a positive coefficient, though it's not coming to be significant, doesn't matter. But why it has a positive impact? As theory says, there should be a negative relationship because of law of demand. Please understand, right now we are not concentrating on R square, adjusted R square. That's not a concern for us. Please don't look at them at all for the time being. Subodh is saying identification problem. And what is that identification problem? Dr. Lena is asking whether the result in SPSS data will be different. No, all softwares will give the same results. People are saying supply plays an important role. But go back to the theory. Quantity of what theory says about law of demand, make certain assumptions. And one of the important assumptions of the law of demand is that price of substitutes are constant. But in reality, they are not. And we can take coffee as a close substitute to tea. And what happens in that case? And again, the culprit is your omitted variable bias, because we have not considered the prices of the coffee. And once you've taken the prices of the coffee, you see what happens. The relationship is coming as per the theory, and that is also coming to be significant, and R square also becomes your high. And that's the impact of the omitted variable bias. Please understand that. So model should be properly specified. If it is not specified, then it will suffer from omitted variable bias and you will be in trouble. Okay. I have a file. I think it's in Excel. So I import it, Excel file, browse. Friends, you will see there is a file quantity and price of tea. Select it. It is an Excel file. Open. And you will get this window. Marvin is asking, is the theory that helps you in identification of the omitted variable bias? The answer is yes. Theory, literature that can help you in identification of omitted variables. Isha is asking me, do we have omitted variable problem in case of time series? Again, if we are going to make use of OLS, then there will be a problem. But if you are using some other method, then it may be possible that omitted variable may not create a problem. So you have to be careful about it. Okay. Click on import first row as a variable name. And then you say okay. And simply regress quantity demanded with the price of tea. Enter. Friends, I tell you, you will not find too much difficulty in learning Stata. Very simple, like regress quantity T with price of the tea. And see, the coefficient is coming to be positive and negative. And if I add the page up to get the previous command, then you add into it price of the coffee, and we get the result. If you want to find out correlation between them, correlate price of coffee and price of tea, and you find there is a positive correlation. And now you can build a story around your findings. Okay, I'm not going into that, but you can do it. Let's take, there is another important file which we have with us. File with no correlation in independent variables. It's a Stata file. You can directly open it up from here. Sorry, I am not going to do that. Let me open it with here. Open. Yes. File with no autocorrelation, with no correlation. Now I show you something interesting. So let's regress y with x1. Sorry. See the coefficient value which we are getting here. And if I regress y with x1 and x2, what I get here, you will find the coefficient of x1 is almost similar, almost identical, not much difference, very minute difference. And that's because of the approximation. Manoj, please listen to me carefully. I understand that it's not possible for a researcher to identify and to establish whether there are omitted variables or not. But if you believe that omitted variables are not going to have any correlation with dependent variable or independent variable, then you need not to worry about it. Because in that case, your coefficients will not be biased coefficients like here. If I show you the correlation between x1 and x2, you will find correlation is 0. And since there is no correlation between x1 and x2, the results are not biased results. Okay? Rachana is asking, there is any difference between regress and rigor? No. In short, you can use the first four letters of a particular command and it works in Stata. Okay. So take care of omitted variable. That's an important learning for us. What if we are not in a position to observe omitted variable bias? Can we do something in this regard? Try to observe it as far as possible. And if they are not observable, then what can we do? Can we do something in this case? Yes. And that remedy is available in panel data analysis. And you know, that's the motivation for me to talk about omitted variable. So panel data structure will help you in taking care of omitted variable bias. 100% no. Major portion of it, yes. Please understand that. We can, but please wait for the answer that we are going to discuss in panel data. Any question before we go ahead? Any doubt? Yes, control variables can help you in taking care of omitted variable bias if the control variables are correlated with variables of your interest. Marvin Sabu is asking if we have data of BSc and a particular company return, are they constituting a panel structure? I will say roughly yes, but I will not advise you go for panel data analysis in that case. Theoretically, yes. In a way, yes. So friend, take a pause and try to recall what we have discussed so far. There is one question that if constant is not coming to be significant, should we take care of it? No. Unless and until theory says that constant is important for your discussion, you take care of it. Otherwise, a constant coming to be significant or not coming to be significant does not make a difference. But do have constant in your regression model. Okay. Uh, Bhumresh Kumar is saying that most of the macro variables are correlated with us, with each other. You are right. And therefore, try to get all possible of them as far as possible. But friend, it may be possible that they are correlated, but the degree of correlation is so small that they are not significant to be taken care of. So friends, now let's move to panel data. And a data set having both cross-sectional data as well as the time series data is called panel data, and it is also known as longitudinal data. So cross-sectional and time series both together gives you the panel data set. A panel data set is a set of XIT and YIT, where I is for cross-sectional structure and T for time structure. So whenever you see a model with both these scripts, that means my data is panel data. Many times the term panel data set and pool data set are used interchangeably, and but technically we can make a difference between them. And the difference is in panel data, the individual, the firm, the companies which are taking are same across. Are being collected across the cross section and the time series, which are same and not different. On the other end, the pool data set may have different individuals or different persons, and you are taking the data over a period of time. Say, for example, we are collecting the intelligence level of class 12 students. So every year we take class 12 students and take the data. And this exercise we have done for the last 10 years. For the last 10-year data, we have class 12 students data, but mind, students are not same. So truly speaking, that cannot be called panel data because your individuals are changing from time to time. You can call it pool data. But you will find many times people are using these two terms interchangeably, but technically we do make a difference between these two. Shakti is asking if error term influences independent variable, will it be a multicollinearity? No, it's not a multicollinearity problem. It is a different problem which we will discuss in the next session. The terms panel data and longitudinal data are used interchangeably. Please note that. Now we have $1 million question. Why panel data? Why should I go for panel data? What is the need? What is the motivation behind it? Can any one of you give me why should I go for panel data? What is the need for it? Why you should take observations of an individual over a period of time? what advantage you get in your research design. Any one of you can give me any hint about it? Rich in information, Pooja Khanna says yes. Makes maximum inferences. Individual firms are saying, but portfolios are sorted on beta every year. Rashmi Chaudhary, please don't mix this methodology with the, pharma French methodology. High degrees of freedom, yes. So many of you have reasons to understand the motivation behind the panel data. Panel data helps in controlling individual unobserved heterogeneity. And we will have a detailed discussion in panel data analysis as we move ahead. And that's a very, very important contribution of panel data analysis. Controlling individual unobserved. When I say unobserved, I'm referring to omitted. So panel data can help you in taking care of your omitted variables. To some extent, I again say to some extent. Okay, panel data gave more information about data, more variability, less collinearity among variables, more degrees of freedom, and thereby you will get more efficient estimates. By studying the repeated cross-section of observations, panel data analysis is better suited to study dynamics of change. Panel data analysis can better detect and measure effects that simply cannot be observed in pure cross-sectional and time series data. Panel data models allow us to construct and test more complicated behavioral models than purely cross-sectional or time series data model. And friends, you may not be able to appreciate now, but all these points which I'm talking about, but as you proceed with your data analysis, panel data analysis models, you start realizing their importance. And panel data has a larger data set and provides larger degrees of freedom. To be precise, with repeated observations of enough cross sections, panel analysis permit us to study the dynamics of change with short-term time series. The combination of time series with cross section can enhance the quality and quantity of data in ways that would be impossible when you use only cross-sectional or only time series. Panel data analysis can provide a rich and powerful study of a set of people if one is willing to consider both the space, the cross-sectional, and the time series data. Okay. So friends, I hope you are able to understand the motivation behind going for panel data. Manoj, this is not cohort analysis. Cohort analysis, I think, is something different. Nidhi is asking a question about seeing the results of different students of the class 12th in different subjects. Will it be a pool data? It will be pool data because you don't have the same students. Okay, so far so good. Why there is a need to talk about different tools of analysis of panel data? Because of its data structure, because of the the behavior of the data, because of the complexity of the data, and to capture the reality, you have to look forward different tools. You cannot use simple OLS. Okay. What comes to your mind when you see X cross? And what comes to your mind when you see this time t. And Stata recognize panel data in terms of xt. So all commands related to panel data starts with xt. Xt summarize, xt sum, xt regress, like that. So xt will be the symbol that will be used for panel data commands in Stata. And you can see the basic commands xt set. This is a command which is to be run before you start working with the panel data, because it set or tell Stata the panel data structure. And in this command, you have to write ID for cross-sectional and time variable for time period. Then xtrag, xtdescribe, xtsum, xttab. So all those are commands you can make use of for panel data in your Stata. Before we start working with the panel data, we must set our data as per the panel data requirement. We have to provide unit or form, identity, variable, and then time. Okay. Many times it might be possible that the forms or the companies which you have, they are having a string or characters as a name, but you can convert them into numeric by making use of this command. IGN company ID, that's a variable, you name it for your codification for the company name. And this is the variable which is in string, and you want to convert it into numeric. Okay. Now let's go to Stata and practice with it. So I again go to file. I think I have to import my data, Excel. What is balance and balance, that we will discuss later on. Okay. We have to prepare our data set for Stata. Yes. And I show you what kind of a data structure you should have for the Stata. Say company name, for example, or a country and year. X, 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 say 2016, 17, 18, 19, then Y 2016, 17, 18, 19. That's how you have to structure your data for processing purposes. And if your data is not in this order, then you cannot use panel data analysis in Stata. So please first you do it, this structure, prepare your data ready for panel data analysis in Excel, and then you import it into your Stata. Okay, so let me browse a file, and I think basic panel data, you just look at this, open, import first row as a variable name, and then you say okay. Uh, Just means asking, will there be a problem when you have the gaps in the years? And no, if are the gaps same for all individuals, or are the gaps are for some individuals and gaps are not for other individuals? If it is for same, no problem. If it is for some, it is not for some, then you will have unbalanced problem and unbalanced panel data problem. And many of the techniques of panel data can work with unbalanced, but some cases you have to have balanced data. Okay, right. So let's see, uh, friends, if you want to see the data, then see here, there are two, I do not know whether you are able to see it or not. You just click them and you will get, you can view the data. This is the data which we have. We have a year, we have a size, we have a company ID, and we have a leverage. Okay. Now I just close it. So the very first command which you have to use is setting your panel data structure. XT set is my command. And first you have to write the company ID. I take it from here and then here. Enter. Panel data variable ID is strongly balanced, and the time variable is from 2004 2013, and my year is changing by 1 unit. That's what it says. Okay. Now let me take summary of it. XT sum, and we get this summary. I don't want the summary about year and company ID. So I have to specify variable in that case, XT sum, size, and leverage. Then you will not get the uh, summary about company ID and year because it doesn't make a sense to us. Sampati Nath is asking, what is the minimum number of cross-sectional units, the time units for panel data? At least 2, maximum no limit. So at least you should have 2 units of cross-sectional and 2 units of time period. Are we supposed to create dummy variables all the time? No. XT set doesn't measure anything. XT set gives instruction to Stata that this is my panel data structure. Okay, right. Now we have something interesting to note here. If you see your output, you get overall, between, within, overall, between, within. What is this that we have to understand? Overall is simple. That means you take the total data and then find out the overall mean and standard deviation, minimum value, and maximum value. That means if I don't uh, use the panel data structure, I just calculate, take summary of size and leverage, you will find the mean value of overall is same, variance is same, minimum is same. That's what we mean by overall. Overall ignores the panel data structure and gives you the overall, the statistics. Okay. Now let's try to understand what is between and what is within. For calculating the between effect, it considers mean of each individual over time. That is, it decomposes xit into a between xi. What does it mean? Let me illustrate to you. You have here, say you have ID, cross-sectional ID, you have a year, and you have size. 1, 1, 1, 1. Year 1, 2, 3, 4. 2, 2, 2, 2, 1, 2, 3, 4. Okay, please understand between. You have a size here. Take a mean for first cross-sectional unit. Take a mean of second cross-sectional unit. Like this, you have a series of mean of all cross-sectional units. If you take a standard deviation of it, that is called between standard deviation. Okay, that what is being shown here. So between means the standard deviation by taking the mean series uh, of the individual cross-sectional units. And please understand this concept of between, because you are going to have a between estimator, you are also going to have a within estimator later on, and then there you must appreciate what is between and what is within. Now let's take within. For calculating the within effect, we calculate xit minus mean of it, and then we add cross-sectional units. Overall, this just to make the things comparable. In that case, what we do is again I put company ID and here size 1, 1, 1, 1, 2, 2, 2, 2, 1, 2, 3, 4, 1, 2, 3, 4. Size, you have sizes x11, x12, x13, x14. Subtract mean of 1, mean of 1, mean of 1. Then here you have x21, x22, x23, x24, and from each you subtract the mean of second. So what you're doing, you're calculating variance or standard deviation within the cross-sectional unit. That's what I understand by, that's what we understand by within. Okay. So I hope friends, you are able to understand. It is not like calculation of ANOVA. Please understand that. ANOVA is something different because ANOVA doesn't have a panel structure. Within effect, you will talk about when when you discuss fixed effect tomorrow. Okay, Soumya is asking why we are calculating it. Just to get an idea where we have more variations. Is it within the individuals you find more variations, or is the across which is more variations? So for example, within the companies you have more variations of a capital structure, or is it across the companies you find more variation? Okay, to get that feel of the data, we get between and within this. Okay, so between is nothing but you take a cross-sectional means and then you find the standard deviation of it. That will be between. All variances are not average. Please don't go into that. Variances are not cannot be averaged. Any question before we go ahead? Any doubt? Swapnil Shah, yes, your response to your question is yes. Three industries, 3-year data, you can make use of panel data structure. Uh, Pooja is asking, what does it mean? X bar means unit mean, and double bar means overall mean. That is mean of mean. That's what double bar, understand it. Endogenous, exogenous variable discussion we will have later on when we proceed with the panel data. Meshwar is asking me within example, suppose you have a cross-sectional unit, 1, 1, 1, 1, here, 1, 2, 3, 4, x. Then if you take deviations of x11 from its mean of 1, then we are calculating within within variance or within standard deviation. Uh, just to make the things comparable, if you don't add it, doesn't make a difference, because adding and subtracting a double a constant will not affect your variance. Sanjay Kumar is again asking me within and between. Please appreciate that, because you are going to use this terminology when you talk about fixed effect model, because fixed effect model is within effect model. Within means, again, I take an example. You have a company ID 1, 1, 1, 1, 1, here. 1, 2, 3, 4, 5. Forget about another company. I want to find out what is the variability, what is the standard deviation within a company. You will say, I can calculate that standard deviation. Suppose this is my variable x, x11 minus mean of company 1. If you do like this, then I'm calculating within standard deviation. Another company, second company variable, deduct from it mean of the second cross-sectional unit. That will give you within. But if you take mean of it, and then calculate standard deviation of it, that is called between. Okay? What next, friend? That we are going to talk about in the next session. And next session, we will start at 12 o'clock. Or sharp 12 o'clock, we will start. Because next session is slightly longer. So we need more time for it.
Thank you, sir.
Thank you.
Thank you, sir, for such a detailed explanation. The
Thank you.
session was quite enlightening and interactive. Uh, in this session, sir has discussed about where we can use panel data analysis, basic command we have in panel data analysis, and also about omitted variable, and also cross-sectional data. I hope those relevant practical example help the participant to understand the panel data analysis. Participant, now we will take a break of 30 minutes. Today we have another session with Professor C.P. Gupta sir. So we are meeting again after the break at 12 o'clock. Thank you, sir, once again.
Thank you, sir. So can I change the slide, sir?